This is Mr. Smarge coming at you with an exciting computer science video. Hope you enjoy.
Today we're going to be working on several review problems involving arrays and loops. So let's get started with number 1 here. We can see that we have an integer array that contains 5, 10, 15, and 20, and we have to evaluate several different values. So I always like to start by listing out the indices of the array. So if we go to array A, I'm just going to write in underneath it 0, 1, 2, and 3, because remember that our indexing always starts with 0. And the length is going to equal 4, and we're going to use that at a later date. So let's start with A sub 2. Since we've listed out our indices, we could see that at spot 2 we have the number 15. So we're going to put 15 down for our answer here. The length we've already noted is 4, so we're going to put down that our length is equal to 4. Part C asks us to find the value that is located at the index equal to the length. Now that length is equal to 4, but this causes a problem. We can see that our indices only run 0 through 3, so there is nothing at 4, so this will give us an error. When we look at question D, they ask us to do some division. So off on the side here, we're going to say that A sub 3 we note is 20, and we have to divide by A sub 2, which is equal to 15. If we use our calculator to find this answer, we're going to get some type of decimal. We're going to get 1 point something. But in Java, because we're dividing integers, we are just going to get 1, precisely 1, because 2 integers divided will always give you, in Java, another integer. And finally, to look at question D, just pan out a little bit here, to answer A sub A dot length divided by 2, well, our length we saw was 4, and when we divide that by 2, of course, we get 2. So this question is really just asking what is A sub 2, and that, of course, is 15. We saw that earlier. So that takes care of the first question, all of the parts. Let's see what 2 brings us. To use a loop to build the elements of an array called A, and there should be 6 elements. So the code has been started for us. So we're going to come down here and we're going to use a loop. So we're going to say for int I equals 0, I less than A dot length, and I plus plus. It's kind of the standard way for defining the values in an array. We're going to loop through systematically from 0 through the end. And we're going to say that A sub I is equal to. So now let's go up top and see what kind of pattern are we dealing with. We know that the indices run from 0 through the length minus 1. All right, so there's 6 elements on the list, but the indices run from 0 to 5. So we notice that at spot 0, the number to fill the array is 1, and at spot 1 it's 2, and spot 2 it's 3, and so forth. We're always off by 1. So we can say that the value at I is always equal to I plus 1. And we can test that out for when I is equal to 0, 0 plus 1 is equal to 1, so that's going to be correct. When I is equal to 1, 1 plus 1 rather is equal to 2, so that is correct, and we see that it's going to work for the rest of the way. So this has correctly defined our array A. Let's go on to the next. Define array B, and this time we have the numbers 2, 4, 6, 8, 10, 12 inside. So let's do our for loop. We're going to start with our for just like earlier. For int I equals 0, I less than b dot length, and I plus plus, and our b sub I will equal, now it's time to look at the pattern, 0, 1, 2, 3, 4, 5 are our indices. And since it goes 2, 4, 6, 8, 10, 12, if you notice, we're always going up by 2 each time. Okay? So we could say that we're going to be at 2 plus 2 times I. So that way when I is equal to 0, we're going to get 2. When I is equal to 1, we're going to get 2 plus 2 or 4. When I is equal to 2, 2 times 2 is 4, plus 2 would give us 6. So when I is 2, we get 6, and everything seems to be working perfectly. So this is the way to set up our array B. Let's check out the next one. C, and we're going 1, 4, 9, 6, 25, and 36. This is a little more challenging perhaps. The beginning is going to be the same. For int I equals 0, I less than c dot length, and I plus plus. And now we see if we can figure out our pattern. So let's write in our indices, 0, 1, 2, 3, 4, 5. I look at all these numbers, and what I see are perfect squares. But it's not 0 squared. The 1, which is 1 squared, is in the 0 spot. The 4, which is in 2 squared, is in the 1 spot. And the 9, which is 3 squared, is in the 2 spot. So the squares are offset really by 1. So the way we can handle this is we say for each one, for each value for I, we're going to let c sub I equal I plus 1 times I plus 1. That way when I is equal to 0, we're going to have 1 times 1, which is just 1, which is correct. When I is equal to 1, we're really going to be doing 2 times 2, and 2 times 2, of course, is 4. Let's check way at the end. When I is equal to 5, we're really going to be doing 6 times 6, which is 36, and that's perfect. So this one is done. Let's go on. Fifth and final problem, and it has a familiar start. We're going to do 4 int I equals 0, I less than d dot length, and I plus plus. And we're going to do d sub I equals, and now it's pattern time. Once again, we will list our indices underneath, the spots in our array, and we look for a pattern. We can see that it starts at 35, and we're going down by 5 each time. Almost like you would have in a line in algebra class. So what we can say is that the starting value is 35, so we're going to start with that, and each time we're going to subtract 5 times the I value. And what that does is when I is equal to 0, all right, so I is equal to 0 here, we're going to just get 35. When I is equal to 1, 35 minus 5 is equal to 30, so that works. When I is equal to 2, 35 minus 5 times 2 are 10. 35 minus 10 is equal to 25, and that works. So we can see that we've started off the pattern correctly, and even if we go to the end, when I is equal to 5, 35 minus 25 is 10, and we see that that works out. So that concludes our review of loops and arrays.
Hope you found the video to be informative. I'll catch you next time.